Hi, Charlottetown. Atomic Amber here from Mad Science of the Maritimes. Thank you so much for having us a part of your Canada Day celebration. I have some really cool experiments coming at you from our friends Radical Rob and Lightning Lily. They're going to show you some cool experiments with dry ice and some fun stuff to do at home, too. Just remember, rule number one of Mad Science is to have fun.
What we have here is a frozen gas. And I have a big old chunk of it right here. Now, when we inhale a lot of a gas called oxygen. Take a deep breath with me. Now blow in your hands. When we exhale a lot of another gas called carbon dioxide. All right, can you say carbon dioxide?
Carbon dioxide.
Very nicely done. Now, if we were able to freeze the carbon dioxide coming out of your body so cold that it turned to a solid chunk of ice, this is what it would look like. Dry ice is a frozen gas. And it's not an easy thing to freeze a gas. To freeze regular old water to get it to turn to ice, we have to get it to about 0 degrees Celsius. But to get this to freeze, we've got to get it to about negative 79 degrees Celsius. Way colder than the coldest winter's day. So we won't be touching it with our bare hands. Now, if this was a regular piece of ice, what would be dripping off of it?
Water.
Water. It would be melting. But this doesn't melt. It goes through a process called sublimation. Right idea. Sublimation is the process where a solid turns to a gas without becoming a liquid. And that's what happens to dry ice. This doesn't melt. That stuff that looks like smoke that's coming off of it, that's actually what the dry ice is made out of. It's solid carbon dioxide gas. And we can speed up sublimation, give me a ding ding, by actually breaking the dry ice up into smaller pieces and doing something that fancy pants scientists call increasing the surface area. I've broken this dry ice up into some small pieces right here. And if, Lightning Lily, if you blow on that, you'll see all that gas come out and we speed up the sublimation. We can speed up the sublimation even further by dropping it into our Erlenmeyer flask. And I'll take my gloves off now because even though the gas, the solid is not safe to touch, the gas is completely safe to touch, okay? In fact, if you open wide and taste it on your tongue and up your nose, delicioso! You can actually taste the gas, and it's a gas that we've tasted in the past. Does it taste like anything to you?
Seltzer.
A little bit like seltzer, right? Because we like bubbly drinks in our family. And so that carbon dioxide gas that they put in sodas and seltzers, it's the same gas that we see in our coming out of our Erlenmeyer flask here, carbon dioxide. Not only is carbon dioxide used to give sodas fizz and make them fun to drink, it's also used in fire extinguishers. Did you know that?
No.
If you want to put out a fire, you can deny that fire of oxygen. A fire needs oxygen, like we breathe in, to burn. You see this fire over here? If I bring my carbon dioxide right over to it, good night, Charlie. That's sublimation. Give me a ding. Back here with a chunk of our dry ice, our frozen carbon dioxide gas. And we're going to see how temperature plays an interesting role in the way dry ice interacts with other stuff. Now to do this experiment, I need Lil, can you add about 2 or 3 drops of food color to our water? Make it nice and visible. Perfect. Give it a little swirl, swirly swirl. All right, we're gonna put it down. And there's a spoon right there. Can you hand me your spoon? Perfect. Now, in the summertime, we like to grill, right?
Yeah.
Have you ever heard when we throw meat or even an ice cube on a grill?
Mm-hmm.
What kind of sound does it make?
Annoying one.
Annoying, right? It's kind of sizzles and sears. All right. Now, do you think this spoon is particularly hot? Yeah! Ooh! No, not really, right? But comparatively speaking, compared to this, it's way, way hot, right? We know that this is about negative 79 degrees Celsius in order to stay as a solid chunk of ice. So this is way, way warmer. In fact, if I were to press this against this piece of dry ice, it would feel to the spoon, if it had feelings, as if it were sizzling, right? Mm-hmm. We're not going to hear the spoon go, ah, I'm sizzling. But what we are going to hear are the molecules come screeching to a halt. And it's kind of sound like sizzling, or almost like, have you ever heard nails on a chalkboard?
Yes.
It's unpleasant. Check it out. Here's an experiment experiment that you guys can do at home. It's called the skater's edge. It reminds me of how ice skaters, you've been skating, right? And you know how the blade sort of digs into the ice? But after you go over it, the moisture refreezes, and so the ice keeps reforming. Eventually a Zamboni comes and cleans up the whole thing. But we're going to do something that kind of replicates or shows us how the blade sort of digs into the ice. Now, in order to do this, all you're going to need are some paper clips and 2 rubber bands. And you're going to want to end up making something that looks like this. So to do that, we're going to take our paper clips, put 1 rubber band through it on one side, and then the same thing on the other side. So it looks something like that. And then we're just gonna finish the loop by adding the paper clip on the other side of the rubber bands too. How you doing there? Looking better than me. Awesome. All right. And then you'll finish it all the way through. So you connect it with the other paper clip. Now, after we've done that, we've got something that kind of looks like a circle, stretches out a little bit. You're going to need, in addition to the 2 rubber bands and 2 paper clips, a plate and a cup. And we're going to stretch the rubber band over our cup like so. Oh, here, you can use this one. This one's ready to go. Actually, yours is ready to go too. That's perfect.
Oh.
So either one.
Please.
All right. While you do that, I'm going to get our ice cubes. And you're going to place, 1 ice cube. That might happen to you too. So be prepared to put this back on a couple of times. Using a shorter cup like the one Lightning Lily has might be better. But you're just going to wedge that ice cube underneath the paper clip. Like I said, it takes a little time, but voila, I got mine. And you're going to want to kind of center it a little bit. How are we doing with yours?
That's good.
Perfect. Nice, okay. And so you're going to leave this alone for about 15 minutes and you're going to come back and take a look. What's going to happen is the pressure from the paper clip is going to start to drive it down into the ice cube. But as it gets driven down into the ice cube, the ice above it will actually start to freeze. And so you'll end up having a paper clip. Here, you hold that one, show everybody. Embedded in your ice cube. And you could do this with multiple ice cubes. See how big you could get your paper clip. See how long it takes to get the paper clip to go even further through. But there you go. The skater's edge experiment. Try it at home. Now, another thing that we like to do is our big finish. Up until this point, we've been doing little experiments in beakers and flasks. But for this next demonstration, I've got about 10 pounds of dry ice right over here and a big old bucket of warm water. So can you give me a countdown? Say 10, 9,
8,
7, 6. You guys too.
5, 4, 3, 2, 1.
Whoa! There's a massive sublimation reaction right there. And you can see what's so interesting about this carbon dioxide gas is that it's heavier than the oxygen in this room. You know how I know that? If it were lighter, which way would it go? It would shoot up like a volcano, but it's so heavy, I can actually fill a cup of gas and pour it in your face! You don't see that every day. Ooh, that's gross. Go for it. Sublimation. Give me a ding ding. That's a big idea.
Thanks, Charlottetown, for having Mad Science a part of your celebration. Have a scientific Canada Day!